Hi, my name is Dan Malone, and I'm just using this recording to respond to a few discussion points that were put up regarding LDL and HDL. So these are lipoproteins, and if we just reiterate firstly before I talk about the discussion question, as you can see here, lipoproteins have a unique protein on their surface as depicted in blue here. So this protein will vary depending on whether it's an HDL, a high density lipoprotein, or an LDL, a low density lipoprotein, or the other types of lipoproteins for that matter. And so this is important because this protein is key in terms of what happens to this lipoprotein. Okay, so just remember that whilst we go through this. So the first question was, while it's clear that LDL can deposit fat in the blood vessel walls, can HDL remove it from the blood and the walls? Well, yes, it can, essentially. So if you think of HDL, I didn't actually go into this much detail in the recording, but HDL is secreted as small discs from the liver. And these discs contain mainly just that protein, that blue protein I showed you before on the surface, as well as some phospholipids, so lipids that have a phosphate group attached to them. And so those HDLs circulate within the blood vessel, and they can acquire cholesterol in that blood vessel, and when they do, they become much more of a spherical shape like this, and so they become rich with cholesterol, and then they take that cholesterol back to the liver, which is of course a beneficial thing because we want to try and lower our circulating cholesterol levels. So they can do this, but they can also migrate as discs into the area where the plaque exists, so where the fatty accumulation exists, and it's this area where they can also extract out lipids and cholesterol from this complex and again take it back to the liver for repackaging into bile acids or being used for another process. So yes, HDLs can extract or get cholesterol from the blood vessel itself and also from the blood vessel wall. Another question was, what's the mechanism by which LDL causes this unwanted effect, so of depositing under the blood vessel wall, I presume you mean, and why do other lipoproteins not have this property? So again, this gets back to the fact that you've got these unique lipoproteins, sorry, you've got these unique proteins on the surface of the lipoprotein. And so because you've got this unique protein on the surface, this dictates what happens to that lipoprotein. And so because the LDLs have a unique protein on the surface, so we'll draw the LDL in blue. So the LDLs, because they have that unique protein, they're able to migrate and therefore deposit into these, or underneath the endothelial layer, or underneath the layer of the blood vessel. It's actually more complicated than this. There's an oxidation step, so a chemical reaction that occurs with a particular cell of the immune system called a macrophage, but maybe we're getting into a bit too much detail. And they basically create what's called foam cells, and these foam cells are called foam cells because they essentially are filled with fatty molecules. And so if you think of a foam cell, we'll just draw a foam cell in a different colour. So they basically just consist of a lot of fat and cholesterol. Cholesterol is fat, but cholesterol and other types of fats like triglycerides into that foam cell, and that's what comprises a fair proportion of that bulge, which is then affecting blood flow through this blood vessel. Okay, so that's the reason why LDLs are able to interact with those cells of the immune system and form foam cells, is because of that unique protein on the surface of their cell again. Okay, so that's really what's key in terms of driving what happens to these lipoproteins. Hope this has been of benefit.